this is the Deephaven community team, March week 1 with another demo. First, we've got Devin to show some cool example he's got with a poll. So here's Devin's demo.
Hey everybody, can you see my screen?
Yep.
Great. So as Bender said, I'm Devin. I'm a backend developer at Deephaven. And this week, I'm really excited about this demo for a few reasons. One, because I typically describe myself as a backend developer like I just did, or everything but front end. And this week, I'm jumping into the front end a little bit with some JS support from Bender. As you can see, my web page right here is pretty snazzy. We've got some text and a white background. So that's my level of design we've got going on right here. And secondly, I'm excited about this week's demo because it's an interactive public demo, at least with the people who are here right now. And so this week I'm going to be demonstrating getting data into Deephaven via REST. So we've got a custom servlet that is running on the Deephaven server, and then we've got some custom JS widgets on top of it. A couple of big caveats here. This is a very small server running in the cloud. It's got one CPU and 4 gigabytes of RAM. So it's like a typical box that you'd spin up for small test projects. And we'll see if it could handle a little bit of stress testing. Second thing is it's an ephemeral server. It's probably not going to be around forever. So it might be up for a couple days, couple weeks. We'll see. And this is my first time writing JavaScript ever. So we'll get a look at a little bit of it to see how some of this stuff is set up. And again, this is a live demo. I've done minimal stress testing, so it may crash. But let's go ahead and jump into it. So this is a poll that I've created that is going to figure out what the best number is. And so users can go ahead and submit a best number here. Don't submit any best numbers if you've got any yet. I want to go through the UI first. Oops, looks like somebody already did. So somebody has already submitted a best number. Looks like 6,060,842. But if we go ahead and let's say I think the best number here is 42, I'll go ahead and submit it. The server agrees with me. The best number is 42. And we can go ahead and jump to the results here. And you can see, okay, we've got 3 results here now. And some results have been collected right here. You might be thinking, oh, this is kind of basic. What I've got here is, let me refresh this real quick. I've just set this up in an iframe to have both these side by side so we can see actually it's going to update in real time. So when I hit this, we'll see we've got another result here. Oops. Maybe our best number is 45, something like that. So we've got a couple different numbers here. And I'm going to describe how these are built. So these are Plotly widgets that are going directly against the Deephaven API. So you can actually run this from CodePen directly. It's pretty simple. You pull in the Deephaven JS API, set up a couple of divs, write some JavaScript with help from Bender. And then basically what you do is you set up a pie chart, a bar chart, and a gauge. So this gauge is actually composed of 2 different tables. The hits within the latest minute, so how many people have submitted a best number within the last minute, and then what's the maximum with any given minute. And so that'll change the max here in a second. And then the pie and the bar charts are counting the top 10 best numbers and the top 5 best numbers respectively in slightly different formats. So the interactive part of this is go to this website and go ahead and enter your favorite number. So it's poll.devinrsmith.com/poll. Looks like we've got a lot of people testing it already. You can see we've got numbers flashing by here. All right, so we're off to the races. I'm not going to juice the results at all. But here you can see we've got some numbers ticking on by here. So you can see we're up to almost 1,500 hits this minute. Looks like 1986 is our winner so far, with 50% of the votes. If you're not sure what's going on right here, some of the developers are scripting this up in curl. And if you want to do that yourself, you can run a command like this from the command line. Let's go back to the results real quick, and we can see how this plays out. And if we sort by timestamp here, we can see all these different numbers scrolling in right here. I guess I should talk about some of these global stats too. So these are the total number of hits we've had this count. We've had 13 unique addresses put in numbers. IDs is the number of numbers that people have submitted. So we have, unique, what is IDs? IDs is like cookies. So we've had 546 different cookies, essentially. 13 different user agents. It looks like all of us have slightly different user agents. Over 1,000 unique numbers. Our minimum number is negative 42 billion, maximum number 6 million, and we've got an average and a median being computed here. And this is all, this is all being done through a custom Plotly JavaScript stuff, and it'll keep ticking away for the rest of the demo, and we'll check in a little bit later to see what the best number is. So I'll hand it off to, I think, Amanda now.
Yep, Amanda's going to show off the Debezium examples, I think.
Yeah, thanks. That was really cool. So we've been working hard on getting this Debezium example going. And so if you go to the Deephaven examples repo, then you'll be able to find the Deephaven Debezium Demo. And so this is written to kind of match one of the examples that was done by Materialize. And it's a really good example to kind of measure the performance of a system, because it's easy to tune, and yet it can also stress the system really well. And so this one is just the Deephaven side of the demo. But if you click on this link, you'll see that there is the Materialize version of the same demo. So you can go ahead and give that a test as well. And I think later Christian's going to go over how to perform them side by side. But you need a little bit more computer power than my little laptop can do for that. So this is designed so that you have a quick start where all you have to do is clone the repo and then go into that repo and then Docker compose up. It opens up the IDE on the normal port, and every command that you might want to run is following along. And so you are going to essentially make some tables in the Debezium platform, and then we're going to send it using Red Panda to Deephaven. So to bypass all of that, we have a script written that we can then just open and read into our editor. And so when we do that, you'll see all of those scripts run, and it takes, a little bit, because right now what it's doing is it's simulating an e-commerce site, and it's keeping track of all of the clicks that happen, all the purchases, and all the information. Now, as you want to run that website and that simulation, you can always go into the environment file and kind of tweak the parameters as you want. But you'll see everything generally loads, and there's a lot of tables here. We have the users onto that simulated website. I think I might be hitting Devin's server too hard still in the background. But then it's running all the thing, and the best table to kind of keep track of everything that's running is the final table that comes up, which is this page view summary. And so that one is really important because it tells us that right now we've had 2 million interactions with that page. And it's just keep on clicking and clicking away. And you'll see how kind of this number compares with Materialize total page view summary next. Okay, Kristen, you want to cover the perfs?
Yep. Thank you, Amanda. So the part that I'm going to show is, as Amanda kind of like preview you, I'm going to show Materialize running side by side with Deephaven. And the script that generates the load, which originally was written by the Materialize guys, is a Python script. It's essentially doing two things. There is a MySQL database, and we are essentially simulating purchases by essentially doing updates in the database. for when a user essentially buys something from the e-commerce website. And then there is page views, and page views are purely Kafka messages. So this is intended to simulate we have some kind of web infrastructure, and we have the e-commerce site being browsed by people, not doing purchases yet, just browsing. And as they jump from product to product, from page to page, when they hit a page, our website backend is supposed to generate a Kafka event so that we know that that page is being hit, and that way we can see which products are being watched more closely, what is hot for people, and things like that, right? This is totally a simulation. There's no real e-commerce website underneath. There's just one script that is making as if our backend was generated these two things: MySQL updates, which from the point of view of an action we call purchases, and page views on the website. The MySQL connection goes to Debezium, which is the change data capture thing that converts those events into Kafka events. So in the end, we get everything through Kafka, but the MySQL part is fully transactional with like event sequence one after the other, and the page views are not necessarily connected to that, okay? So I'm going to share my screen now.
There we go.
Yep.
Yep.
So just for you to know, what Amanda was showing you is the demo that is in its own separate Git repository. What I'm going to show you is essentially inside the canonical Deephaven core clone. We haven't extracted the perf part of the demo yet. So I'm just in Deephaven core, okay? I mean, you can run this yourself if you want from Deephaven core. But I'm going to be using the Docker Compose hierarchy that we have there with some dependencies to the file side. So inside the Debezium directory under the Deephaven core, we have demo and perf. What Amanda just showed you is the same inside the demo directory. And I'm going to go into the perf directory. We have two other things here. We have loadgen and scripts. Loadgen has the Python code for our simulation of the e-commerce website, and it's shared by both demo and perf. Demo and perf have different Docker Compose files, and in scripts there are two files: demo.py, that's the Deephaven table code, and demo.sql, which is the SQL commands for Materialize. So let me quickly give you a glimpse of what this looks like. So this is just a couple of table defines in Deephaven based on consuming from Kafka. Relatively long. 191 lines. And then we have scripts demo.sql. The similar thing for Materialize. This looks like SQL commands, and the particular kind of ticking tables that Materialize creates are called Materialize views. So their commands for that is this create Materialize view. Okay. So when we wrote this conversion of their demo, this is originally their e-commerce demo, we essentially translated all that SQL into Deephaven table operations that should have, to the best of our abilities, the same semantics that their tables have. Okay. So our intention is that tables with the same name match tables with the same name in Deephaven in terms of meaning, in terms of semantics, okay? Okay, so I'm just going to go to a different window, and I'm just going to start the Docker Compose here in the perf directory. While that starts, I'm going to give you a quick glimpse at what that Docker Compose file has. We have a couple of services, as you would expect. Deephaven itself is here. Some Java options depending on the environment definitions. All the ancillary services that we need for Deephaven to work, your gRPC proxy, the web, Envoy, and then we have Red Panda. Red Panda is going to be shared. It's going to be the same Red Panda feeding both Deephaven and Materialize. We have MySQL. We have Debezium. We we have the simulation script, and then we have Materialize itself. Materialize is two images. One is the engine, and another image is the command line interface to Materialize when we can do the SQL statements, okay? So I'm going to jump back to the window where we're running the compose. So the compose is running now. We have Deephaven running. If we scroll back, we probably would see a lot of initialization code. It takes a while to initialize. You cannot start Deephaven right away because Debezium, you cannot essentially read the script and try to run it right away because Debezium has to do some amount of initialization. So it takes a couple of seconds, okay? So I'm going to start our console. And I'm going to do the same command that Amanda showed before. I'm just going to load our code for the demo. I have same tables here. And now I need to do the same thing for Materialize. So I'm going to run the command line interface for Materialize. It's also inside the compose, so I just use Docker compose to run it. It doesn't start on its own, this part. The Materialize engine does, but the command line interface doesn't. And here, this is PSQL, which is the Postgres interface, the Postgres command line interface. And Materialize uses exactly the same protocol, so you can send commands to Materialize using the psql command, which is a standard Unix command that you can install in any Unix distribution. Postgres is open source, right? So we say scripts demo.sql, and as it runs, it gives some feedback. We created the sources you asked for, we created the view, etc. Right? So now that all that is created, Materialize is actually in the background, keeping track of these streaming tables, of these sticking tables in a similar way to what Deephaven does. There is no UI for it though, but one thing that we can do is we can run one psql command that is going to run a select, okay? And we can run that into watch once per second. So what we're going to be doing here with this command is that this command is going to execute psql-c and that select statement as an argument to psql once per second. And that's going to give us some output that we can watch for the equivalent table that we are looking at here, which is our page view summary, okay? This is the total number of events that we are processed so far. What we're doing is that we are having purchases and page views. The event that we're going to dial up is the action that we're going to dial up is the page views. That essentially does not need MySQL under the hood, which is a little bit heavier. It just needs Kafka. It's just one Kafka event. So right now we're running 50 per second. It's a configurable parameter for the Docker Compose when it starts. It's the same value that the original Materialize demo uses by default. And we modified the script so that we can have the ability to change that on the fly. So I'm going to do that in a second. Before I do that, I want to show you the output from top in the machine where all this is running, right? All these Docker images in the Compose are running in one machine. This top is from that machine. Right now, we have Red Panda as the top one, essentially using one full CPU. We have Materialize using around 45% of CPU. And we have Java, which I think is our Java. You see, there are a couple of Java here. I'm going to press C in top so we can see the command line. And yeah, this is our Java, this is Deephaven. Right now, we're not using a lot of CPU. We're using between 2 and 4%, right? Sometimes it jumps a little bit more. Now it's 30%. It goes back to 2%. So these are our three top processes for what is essentially generating load right now. The script that is generating the load, the simulation, is this PyPy generated load.py. PyPy is an alternative to CPython. So we are essentially running Python, but we're not using CPython, which is the canonical, more common Python interpreter and runner. We're using a different implementation that is called PyPy, which for our purposes is good because it's a lot more efficient from the point of view of CPU utilization. So it's not going to end up competing with what we really want to measure, or not that much. So what I want to do now, just let me show you that I have enough CPUs here for all this stuff to actually be running in parallel. This machine has 20 CPUs, 10 real CPUs, 20 CPU threads. And we have enough memory for all this stuff to be running at the same time. The resident size is what we really should be paying attention to in terms of memory. And the percentage CPU. So those are the two resources that we're going to care about, okay? I'm going to go here. The generate load script listens on a socket for a very simple-minded command line interface where you can tweak the rate of messages that are being generated. So I just connected to the load gen script. It gives me a simple-minded reading, and I'm going to say set page views per second to 10,000, let's say. So it's like, okay, I'm setting page views per second for you to 10,000. We were sending 50 before, now we're sending 10,000. If I go here to the output of the compose, I'm going to wait for load gen output. I'm going to freeze the screen with Control S. You can see here it says simulated 28 purchase actions in the last 10 seconds. We are not increasing the purchase, but we should have a similar line for, page view action. So 98,000 page view actions in the last 10 seconds, effective rate 9,800 per second. It's not exact. It's essentially using a very humble attempt at a traffic shaping algorithm for trying to keep a constant rate. It's very hard to do that for a higher end rate. So we're going to get close, but not exact to the number that we asked for, okay? I'm going to release the screen so that this can scroll. I press Control Q before I press Control S to stop it. Now I press Control Q to let it resume. And we can go back to the output of top to look that now there is more CPU utilization. Things are essentially eating more memory and eating more CPU. We actually eat more memory than Materialize, but Materialize is eating a lot more CPU than we do at this level. Okay, it's almost getting 2 full CPUs. We're still 30%. The amount of memory that we consume has to be taken with a grain of salt because this is Java heap, right? So essentially we configure a maximum heap, and Java, the runtime, is using some part of the heap that we configure. This is our default configuration. We are not doing anything special here. It's the exact same default configuration that we have for the Deephaven core top level Docker Compose. So this is 4 gigabytes of heap, okay? Materialize doesn't need to configure a maximum heap because it's not Java, it's Rust underneath. So it just requests more memory from the operating system as it needs more. And eventually it could run out if we run out of memory in the machine. But right now it's using 1.5 gigabytes, okay? So I'm going to push this a little bit higher. I'm going to push this to, well, I'm not really being honest. I'm going to push it a lot higher, 50,000. So let's give it a little bit so that it can ramp up to 50,000. Let's see the next refresh of the load hand line so that we can say, yeah, it's getting close. 49,500. That's not too shabby. Cool. We go to Deephaven. We see this is still updating. We have so far 2 million events in total. This delta time is an attempt to measure how long it takes from the time of the last refresh to when we are actually getting that event calculated. Okay, so the events that are showing up from Kafka have a timestamp when we read them, right? And at the point the update cycle in Deephaven runs, at that point we use datetime now, and we take the difference from that event, the last event that we read, and we paint this number here. And right now that number is at 167 milliseconds, 199, 200, in the order of 200 millis, 0.2 seconds. Okay. If we go to the Materialize output for the same thing, we see 25 milliseconds. That's interesting. But one thing that we notice is that the math received timestamp kind of jumps. It's not moving. So we are getting stuck. This doesn't refresh in a couple of seconds. So what is happening here, I believe, is that we are falling behind. And if we can here and see from the point of view of memory utilization and CPU utilization, is a lot higher. Our utilization is also higher, by the way. If you remember, we were before 30%. Now we're at 1 full CPU. Materialize is at 2.4 CPU, but it actually, at this point, it needs more. And one thing that I didn't mention before, Materialize is also running with its default setting. So we have just 2 CPUs for Materialize right now as a bound. So what I'm going to do is that I'm going to stop this, and I'm going to modify it's actually not here. It's in the M file. I'm going to modify the number of workers for Materialize, and I'm going to increase the number of workers to 8. So now we're going to give Materialize 8 CPUs, okay? So I'm going to restart. I'm going to let us see a little bit of the composed initial output. We have a lot of initialization for MySQL, some Red Panda. The green is Red Panda right now. Debezium. And at some point, it settles. And when it settles, I actually can connect Deephaven and run our queries, and connect Materialize and run our query. So I'm going to do that. Here, the psql command stopped working because we stopped the previous run. So I'm going to just run this again. All the views defined. Run the psql again. Okay, so we're rolling. We started on the default of 50 messages per second again. So I'm going to push it higher. Connect again. I'm going to go to the 50,000 again. Let's give it a few seconds to get to 50,000. So you see here we are at 13,000. Let me show you how it's like ramping up, not instantly, right? So eventually we will get to the 50,000. Typically after a second or two, but it only refreshes once every 10 seconds because it doesn't want to spam. So here we have load gen. Yeah, we are at 49,400. That seems to be good enough. Let me release that so I can continue scrolling. And I'm going to run prop again. With C. And Materialize now is using 8.5, 8.3 CPUs. We gave it 8. It's actually using them. It's really using them, right? It's now keeping up. This is refreshing much more frequently. You see this, the numbers are changing, 12, 15, 16. Before they were not changing, 18, right? So now it's able to keep up, okay? So, you know, I'm going to be really evil and increase this thing to 200,000. And I won't bore you anymore, I promise. This is the last thing, last part of the demo. So now we're going to have 200,000 messages per second. We were at 155,000 here. Okay, we're at 197 here. I think we're good. Deephaven is still ticking. We are beginning to fall behind a bit though, because the update cycle should be 1 second, right? We update on a cycle of 1 second by default. That's configurable, but it's 1 second by default. We are falling behind. Is getting behind, right? But we're using 1.7 CPUs compared to the 8 CPUs that Materialize is still using. Materialize cannot use more because we just gave it 8 as a maximum, right? And this is, again, not refreshing very frequently. So yeah, that's it. That's our perf demo.
All right, cool. Well, that's it for this week, and we'll see you next week with another demo. Bye.
Hey, do we want to check back in, Bender?
Oh, sorry, yeah. Let's check back in with Devin with his poll here.
Yeah, here we go.
Yes.
Let me go ahead and present a window here.
See what the best number is.
Poll results. And here we are, still ticking away.
Drum roll. Yeah.
We've got a lot. It looks like somebody was just incrementing the best number every time, so they were lying and not actually telling us their best number because we have 25,000 unique responses. But it looks like the number 41 is the favorite with about 33% of the vote so far. I can tell you we are pushing this one CPU VPS to its limits. It is pegged at 100% CPU, and so we are probably getting the maximum throughput out of it that we can. As far as how many messages we are able to get per minute, you'll see that our maximum here is somewhere up past 20,000, and we can actually go look at some other tables that are in the back end to see exactly what some of this data looks like. Here's this long tail I was talking about. We've got a very long table, 31,000 different numbers, but here are the top results and their counts right here. And then here is the time. Let me refresh this real quick. These are the time bins and how many messages came in that minute. So it looks like at peak we were able to get about 23,000 poll results in per minute, again on this very small one CPU server. And you can see even over here in CodePen, it's still ticking away. And yeah, congratulations to number 41. It is now officially the best number. So there we go.
All right, wicked. Well, thank you all. That's all for this week. We'll see you again next week with another demo. Cheers.
Bye, everybody. Have a good weekend.
Do you want to stay on?
I made one